All right, Northern Oklahoma College, College Algebra, Math 1513. This is chapter 1.3, and I'm working an example for number 33 on your homework. We're doing quadratic equations. We've already learned how to solve by factoring and using the zero product principle. We've learned to solve by using the square root procedure, taking the square root of both sides. And now we're learning a third method of solving quadratic equations, and that's by completing the square. Now a little preview of what's getting ready to happen is we're going to mess with this equation here and turn it into something times itself equals 0, which we're going to write as something squared equals 0. That's why they call it completing the square, because we're turning it into something squared. And from this point, you guys know what to do. You're going to take the square root of both sides, etc., and finish solving that. So that's a preview of what's coming. So we start with this, x squared plus 2x minus 8 equals 0. What I need is, I need the perfect number in this spot right here. And I'm just going to tell you right now, negative 8 is not the perfect number. So what I need to do is move it out of the way. I'm going to move it over to the other side. And I'm going to put the perfect number there that'll make this break into a perfect square. So I added 8 to both sides. That basically eliminates the 8 from the left side of the equation and moves it over to the right. Notice that negative 8 becomes positive 8 when it changes sides, when it goes over to the other side of the fence. So now I have x squared plus 2x, and I'm leaving a little space there for that perfect number. I call it the magic number, okay? Just the right number that makes that break into a perfect square. Now, how do we calculate that? We look at the number in front of the x, that 2. And step 1 is take half of that number. Take half of the number in front of the x, which is 2. Taking half of something means 1/2 times 2, and 1/2 times 2 is simply 1. So that's step 1. Step 2 is square it. So I square 1, and in this case it doesn't change. Usually it'll get bigger. So I square 1 and I get my final answer of 1, which is my magic number. Alright, so I take my magic number, 1, and it's positive, and I add 1. But remember, this is an equation. You can't just go adding 1 to the left side without adding it to the right. So I got to add 1 to the right to keep everything balanced. Now what I've done is I've created a perfect square. I've created something that will factor into something times itself. And over here I have 9. Now a little secret is, what's this number here? Well, a little secret is, if you remember at step 1, when we got that answer, that 1 right there, a little secret is that number right there will be the number that it breaks into. That'll save you some time and heartache if you just remember that. The answer you got for step 1 goes in the parentheses. The answer you got for step 2 is your magic number, and you remember where it went up here. Alright, so we used all our tricks and got x plus 1 times another x plus 1 is 9. Remember, I can write this in a shorter way by saying x plus 1 squared, since it's times itself, equals 9. That's the whole reason we did it. That's the whole reason they call it completing the square, is so that you end up with something squared. And now you guys know the rest. It's just the square root property now, square root procedure. So I take the square root of both sides, because a square root cancels out a square, leaving just our x plus 1. And on the right side, I have plus or minus. Remember, I was supposed to put it right here. Plus or minus the square root of 9. I minus 1 from both sides to get the x alone. My 1's canceled, they're gone. X is alone. And I have plus or minus square root of 9 minus 1. But that needs to be simplified further. I see that the square root of 9 is 3. I have a plus or minus symbol in front of it, and minus 1, and now I can split into my two answers. X equals my positive 3 minus 1, or x equals my negative 3 minus 1. So x equals 2 or x equals negative 4. A shorter way of writing it would be x equals 2 comma negative 4. Either way, you can write either one of these as the answer. If you like writing, use that first one. Alright, an example for problem 39. We're going to get into some fractions, but don't be scared. First of all, the minus 2 is not the magic number. I got to move it. So I add 2 and have x squared plus 7x, leave a blank, equals 2. Let's calculate that magic number. Remember, I take half of the x number and square it. So off to the side, I'm going to do my little calculations here. I have to take half of the x number, so half of 7. Well, you could say that's 3.5, which is hard to work with, or 3.5, or just leave it 7 over 2. And since we're dealing with fractions, I'm just going to leave it 7 over 2, and let's see what happens. Second step, you take your 7 over 2 and square it and get 49 over 4. 49 over 4 is my magic number. So my magic number goes right there in the gap where I left a room for it. Add 49 over 4 to both sides, don't forget. And I've created the perfect square. Now if you guys remember, the number we got here on step 1, the little secret is that number is going to be what goes in the parentheses. There, see how easy that is? Just goes right there. On the right side, I'm just going to change 2 to 4 over 4. Whoops, that's a mistake. How about we change it to 8 over 4? So I'm going to change 2 to 8 divided by 4, just so I can get a common denominator and add those fractions together. And I have x plus 7 over 2, all squared, equals 57 over 4. Now the rest of it is just the square root procedure. I take the square root of both sides. Remember, a square root cancels a square, leaving just my x plus 7 over 2. And don't forget to put a plus or minus in front of every square root that you do. So that's what I have now. X plus 7 over 2 equals plus or minus a scary square root, 57 over 4, which we'll try and simplify a little bit here in a minute. Remember, though, I need to get the x alone, so I need to get rid of 7 over 2. So I minus 7 over 2 from both sides. That gets my x alone. All right, I'm looking at that scary square root, 57 over 4, and I noticed that 4 on the bottom is a perfect square. So I use a little trick. I give each one its own square root. So 57 gets its own square root, and 4 gets its own square root, because I know the 4 is going to simplify here in a second. You guys should be always looking for those perfect squares. And so I'm looking at square root of 57 over, now the square root of 4 simplifies to just the whole number 2. So 2, square root of 4 is 2, no square root, minus 7 over 2. Now I'm getting somewhere. Notice I have two fractions. I have a common denominator. All I need to do is combine those two fractions into one with that denominator of 2. So I have my fraction with my common denominator of 2, and I'm just going to combine the tops. So I have plus or minus square root of 57 minus 7. Those are my numerators. All over 2. And technically I'm done. I mean, that's good. But remember, we always want to write it with the best possible, mathematical grammar. So let's put the whole number first and that weird radical second. And we end up with this. Negative 7 plus square root of 57 over 2, or negative 7 minus square root of 57 over 2. That's a better way of writing it. Always put the real or the whole number first. All right, this is an example for number 43. Now, what else can they do with you to mess with you? They can give them to you out of order is what they can do. Remember, what we're doing is we're taking our x squared, and then we're having our x term, and then we're leaving a blank where that magic number goes, and then we'll have equals, whatever's left over. So that's kind of the order we want to get in. We want an x squared and an x on the left, and just whatever's left over, put it on the right side of the equal sign. So we got some reorganizing to do. I want to move this x term over to the left to join the 4x squared. I like the x squared where it's at. It's positive, and we love positive x squares when we're doing any kind of solving quadratic equations. So a positive 4x squared on the left is awesome. Let's bring the x term over to join it. So I add 4x to both sides. That makes the 4x disappear from the right, basically moves it over to the left. Notice that the 4x was negative on the right side of the fence, and it's positive on the left side of the fence. Whoops, excuse me. That's a handy trick. Anytime you jump something across the fence, it just changes sign. It's kind of a quick way of moving things around. All right, and I have my space for my magic number now, so let's do a magic number calculation. So remember, to calculate the magic number, you need that number by the x. And I came over here to the right and did my work. So you take half of that number by the x, and then you square your answer, and this is your magic number, 4. So I add 4 to both sides. That's my perfect number, my magic number, which splits this into something times itself, a perfect factor. On the right, we have 17, 13 plus 4. Now you guys remember the trick over here, the answer to step 1, that's actually the number that's going to go in your parentheses. So remember that trick and write it down for your test. Oh, you know what? You guys are going to have to do some erasing, and I apologize. I made a mistake, and I did not catch myself. I was just on a roll here and wasn't paying attention to my notes. So we need to back up to before we calculate the magic number. My fault. Sorry. Okay, we're here. We moved the 4x over. We have left a space where the magic number goes. But you know what? This trick doesn't work right unless your coefficient of x squared is 1. So what we need to do is we need to change that coefficient of x squared to 1. The easiest way to change that x squared to just a plain x squared is to divide that 4 off. Now, can I just make that first term 4 times smaller? No. I have to make everything 4 times smaller. I have to divide everything by 4. Okay, that was a mistake I made. In order for this to work, the x squared has to have a coefficient of 1, or if you want to think of it as being by itself. So our x squared is alone. We have plus x. I'm leaving a space for that magic number. And over here I have 13 over 4, which I could change to a decimal, but let's just leave it as a fraction and see how it plays out. Okay, so I snuck over to the right to do my calculations for the magic number. Now remember, for the magic number, I need the number in front of the x, which in this case is a 1. If you don't see a number, there is an x there, so assume there's one x there. So 1 is the number I'm going to use to make my calculations. So half of 1 is 1/2, that's step 1. And square 1/2 and you get 1/4. So my magic number is going to be 1/4 that I'm going to add to both sides. Alright, I add my magic number. It splits into x plus 1/2 equals x plus 1/2. Remember, the answer to step 1 over there is what goes in the parentheses. I rewrite it as x plus 1/2 squared equals 14 over 4. Just leave it as a fraction for now. Let's see what happens. Now I'm going to square root both sides. Alright, square root both sides. Remember, a square root cancels out a square. And don't forget to put your plus or minus in front there. I have x plus 1/2 equals plus or minus. Now I used that same trick and gave each one its own square root, which changes that square root of 4 into a regular 2, an integer 2. To get the x alone, I minus 1/2 from both sides. And I'm going to write it the correct way this time. I'm going to put the real number first, and then plus or minus the square root. Now, since they have a common denominator of 2, I'm going to combine these two fractions into 1 with a denominator of 2. And there's my final answer. Okay, and a final example for problem number 47. 9x squared plus 12x plus 5 equals 0. That 5 is not the magic number, so I'm just going to go ahead and move it out of the way. So 5 is canceled, and I have 9x squared plus 12x equals -5. Now, I'm not going to make the same mistake I made last time. Remember, this x squared needs to be by itself. We need to get rid of that 9. So I'm going to divide everything by 9, make everything 9 times smaller. And I get x squared, which is what I wanted for this to work, a plain x squared, plus 4 over 3x when you reduce 12 over 9, equals -5 over 9. All right, let's calculate that magic number. All right, so half of the number by the x, half of 4 over 3 is 4 over 6. I'm actually going to go ahead and reduce it to 2 over 3. And then I square 2 over 3 and get 4 over 9. All right, I'm going a little faster now because I'm running out of time. So 2 over 3, remember the secret, the answer to that part 1 there, or step 1, is the number in parentheses right there. So I have x plus 2 over 3 squared equals -1 over 9 after I do the math. Now the square root procedure. So square root cancels a square. Don't forget your plus or minus in front of that one. And don't forget to give each one a square root on that right side there. All right, we've got a little trouble on the right side. I'm going to go ahead and simplify it because it's making me nervous. Square root of -1, you guys remember you can't do square roots of a negative number, but we do have that defined as I for imaginary. Square root of 9, we can do that. Square root of 9 is just a regular 3. All right, and so I have x plus 2 over 3 equals plus or minus I over 3. You can put that plus or minus like halfway up the fraction, or you can put it on top with the I. Either way is fine. I minus 2/3 from both sides to get the x alone. And we finish it. Remember, it's better if the whole number comes first, so -2 plus or minus I, all on top of 3 is the best answer.